Did you know that our days are, in fact, getting shorter? It may sound unbelievable, but recent scientific observations show that the Earth is spinning slightly faster than usual. This means the length of our day is decreasing by a tiny fraction. While we're only talking about milliseconds, this change has sparked both scientific curiosity and public wonder today. We will explore a remarkable phenomenon and its scientific analysis. How Earth's rotational speed has increased in 2025 compared to the norm, and the resulting changes in the length of our day. In this documentary, we will investigate the mysteries of Earth's rotation and time, the history of day length, recent statistics, potential causes, and its impacts. Prepare for a complex yet fascinating journey deep into the daily rhythm of our own planet. Earth is a cosmic marvel, spinning on its own axis. We know that a day is 24 hours, which is the time it takes for the Earth to complete one full rotation relative to the Sun. This is called a solar day, which averages 86,400 seconds, exactly 24 hours. However, it's worth noting that if the Earth completes one rotation relative to distant fixed stars, it takes about 23 hours, 56 minutes, and 4 seconds. This is a sidereal day. But during this time, the Earth also moves slightly in its orbit around the Sun. The extra time it takes for the Sun to return to the same position in the sky makes our solar day about 24 hours long. We generally refer to the solar day. The interesting thing is, the Earth doesn't spin in exactly 24 hours. Sometimes it takes a little more, sometimes a little less. The difference is minuscule, in the order of milliseconds, a thousandth of a second. The introduction of atomic clocks in the 1950s made it possible to measure these tiny variations. Scientists use these incredibly precise atomic clocks to determine the subtle daily fluctuations in time. An atomic clock is a device that uses the vibrations of specific atoms to count seconds, providing an extremely stable and reliable standard for timekeeping. A term used to measure the length of a day is LOD, or length of day. It signifies how much longer or shorter a particular day's actual duration was than 86,400 seconds, expressed in milliseconds. For example, if a day has a load of minus 0.5 milliseconds, it means that day was half a millisecond shorter than 24 hours. In other words, the Earth completed its rotation in 0.0005 seconds less than 86,400 seconds, spinning slightly faster than normal. And if the LOD is plus 0.5 milliseconds, the day was slightly longer. The Earth spun a bit slower. While these millisecond level changes are not noticeable in our daily lives, they are extremely important from a scientific and timekeeping perspective. Over the long term, Earth's rotation is gradually slowing down. It is estimated that a day is lengthening by about 1.8 milliseconds per century on average. This means that millions of years ago, a day was significantly shorter than it is today. But the crucial point is that even with this long-term slowing trend, in the short term, from day-to-day or year-to-year's rotation sometimes speeds up and sometimes slows down. It's not absolutely constant. Many factors can influence Earth's rotation. Gravitational pulls, especially from the Moon and Sun, create tides on Earth, which cause friction that gradually slows the rotation. The interaction between the solid crust and the liquid core coronal coupling can also alter the spin speed. Furthermore, mass distribution changes in where mass is located on Earth affects the rotation. Major earthquakes can shift land masses, glaciers can melt and add water to the oceans, and large reservoirs can be created. All these events redistribute mass, sometimes speeding up Earth's rotation and sometimes slowing it down. So far, we've learned that a 24-hour day is just an average, and Earth's rotation varies with tiny fluctuations. You might be thinking, few milliseconds more or less, so what? Truthfully, This subtle difference has no significance in our daily activities. But from a scientific standpoint, these changes are highly significant because over a long period, small differences can accumulate into a large one. In the next section, we'll see how these subtle millisecond fluctuations have brought issues like the leap second to the forefront. When the Earth formed 4.5 billion years ago, it's thought that a day may have been only about 6 hours long. After the formation of the Moon, Earth's rotation gradually slowed over time, making the days longer. Millions of years ago, the length of our day was not what it is today. On a geological timescale, Earth's rotation has gradually slowed, lengthening the day. The main reason for this is the tidal forces caused by the gravitational pulls of the Sun and Moon, which continuously slowed down Earth's rotation. In this process, the Moon also drifts away from Earth by about 3.82 centimeters each year. Narrator. Scientists have learned from ancient fossils and geological evidence that days were much shorter millions of years ago. For instance, 1.4 billion years ago, a day might have been just 18 hours and 41 minutes long. During the age of the dinosaurs, about 70 million years ago, day was approximately 23.5 hours. This means a year had about 372 days. Although the total length of the year remained the same, Earth's orbital period around the Sun doesn't change. Because the days were shorter, the number of days in a year was greater, and the cycle of sunrise and sunset occurred more rapidly. How do scientists know the length of a day so far in the past? For example, some ancient corals and clam fossils have daily and annual growth rings. By examining these, scientists can estimate how many days it took to complete a full cycle in a year back then. One study counted the daily growth rings on a fast-growing clamshell from 70 million years ago and found that a year had about 372 days, with a 23.5-hour light-dark cycle. This is the most accurate measurement from the Cretaceous period, confirming that the day was shorter than it is now, although the long-term trend is for Earth's day to lengthen. This change is very slow, just a few hours over millions of years. For example, 600 million years ago, a day was about 21 hours long. It took hundreds of millions of years to reach today's 24 hours. Therefore, in historical times, like a few thousand years ago, the length of a day was almost the same as today, with no significant difference. For instance, in the Bronze Age, the daily time might have been a few milliseconds different, but there was no difference in terms of hours. However, ancient astronomers couldn't directly perceive such subtle changes. But by reviewing their records, today's scientists have gotten hints. For example, in the 17th century, the great astronomer Edmund Halley analyzed records of ancient eclipses from 120 to 300 BC. and found that they occurred slightly earlier or later than modern calculations predicted. He realized this was because Earth's rotation had been slowly decelerating over centuries, making ancient days slightly shorter than today's. Thus, comparing observations from Babylonian and ancient Greek astronomers with modern physics models has indicated subtle changes in day length even over a few thousand years. Of course, some sudden events can cause abrupt, small changes in Earth's rotation. For instance, powerful earthquakes like the 2004 Sumatra earthquake or the 2011 Tohoku earthquake in Japan slightly accelerated or decelerated Earth's rotation a change of only microseconds. But these changes are so tiny that we don't feel anything in our lives, and they are only detectable by sensitive instruments. In summary, on a geological timescale, Earth's day has progressively lengthened. In prehistoric times, the day was much shorter, for example, 23.5 hours during the time of dinosaurs, and in the future, the day will become even longer. It's estimated that in about 200 million years, a day will be 25 hours long as the moon moves farther away. However, amidst all these slow changes, scientists have recently noticed a reverse trend over the past few years. Earth's day has been getting slightly shorter, which doesn't fit the normal pattern. Now, we will discuss these contemporary observations. In 2020, scientists noticed a startling change. While we generally think Earth's rotation is slowly decelerating, it turned out that in recent years, the Earth has been spinning slightly faster. The international organization that keeps track of these changes is the IER's International Earth Rotation and Reference Systems Service. Using highly accurate clocks and astronomical observations from around the world, they report daily how different the true day was from 86,400 seconds. It is from this institution and other observatories that we know what has been happening to the length of our days recently. The year 2020 was unique in this regard. All of the 28 shortest days recorded since modern accurate measurements began occurred in 2020. This means that day after day in 2020, the days were slightly shorter than the standard 24 hours. In fact, before 2020, the shortest day ever measured by atomic clocks was only minus 1.05 milliseconds shorter than normal. But that record was broken in 2020. On July 19, 2020, the day was about minus 1.47 milliseconds shorter, setting a new record. Not only that, a total of 28 days in 2020 were so short that they surpassed all records from the past few decades. The trend of faster rotation continued into the following year. 2021. Although it was slightly slower compared to 2020, the shortest day of 2021 was on July 9th, which was about minus 1.46 milliseconds shorter, close to the 2020 record. Then, a new record was set in 2022. June 29, 2022, became the shortest day of the modern era, with a length about minus 1.59 milliseconds shorter. Imagine nearly 1.5 milliseconds, less than 24 hours. This stunning new record sparked curiosity in the scientific community and was reported in the media with headlines like Earth's shortest day. Many people asked, does this mean our planet is progressively speeding up? Scientists clarified that this millisecond-level decrease would not affect daily life, but is a piece of data that raises new questions about our planet's internal processes. On July 26, 2022, another day was recorded at nearly minus 1.50 milliseconds shorter, meaning multiple events close to the previous record occurred that year. In 2023, the Earth continued to spin at a relatively fast pace, though it did not surpass the 2022 record. The shortest day of that year was recorded on July 16, 2023, at about minus 1.31 milliseconds shorter. Then came 2024, which broke all previous records to produce the shortest day in our known history. On July 5, 2024, the Earth completed its daily rotation 1.66 milliseconds early. That day was 1.66 milliseconds shorter than 24 hours, the shortest day recorded to date. Looking at the trend of the shortest day of the year from 2020 to 2024, it seems as if the Earth is breaking its own record every 2 to 3 years. This trend of consecutively shorter days over several years is truly a mystery and a source of wonder for scientists. From the graph above, we can see how a trend of subtle decrease in Earth's daily rotation time load has emerged since 2019. The small vertical fluctuations in the chart show the normal monthly oscillations due to the Moon's position, and the lowest point of a wave in the middle of each year around June-July represents the shortest day of the year, especially in 2020 and 2022. These points dropped significantly, meaning new records were set for shorter day lengths in those years. In summary, since 2020, the length of Earth's day has been progressively decreasing. According to historical records, the value for the shortest day has been newly set in several consecutive years, which has never been seen before. While it is uncertain how long this trend will last or if it will be permanent, we are observing its effects up to 2025. Now we will look at the events of the special short days of 2025 and then explore why this is happening. In the summer of Scientists have predicted that while a new record for the shortest day of the year may not be set, several days will be significantly shorter than normal. The focus is on 3 dates in July and August. The International Earth Rotation and Reference Systems Service, IERS, has identified July 9th, July 22nd, and August 5th, 2025, as dates when this time-shaving event will occur. These days will be among the shortest recorded since 2020. Let's look at these special days. July 9th, 2025. On this day, the length of the day may be about -1.30 milliseconds, shorter than the standard 24 hours. This means the Earth will complete a full rotation that much earlier than its normal time. July 22nd, 2025. Another potentially fast day, where the Earth might complete its rotation in about -1.38 milliseconds less time. August 5th, 2025. This could be one of the shortest days of that year. The length is estimated to be about -1.51 milliseconds shorter. This means the day will end about 1.5 milliseconds earlier than 24 hours. It's important to note that the above values are just forecasts based on observations and models. In reality, they may vary slightly, but the overall picture is that in mid-2025 July-August, there will again be some days when the Earth trims a little time, so to speak. After the record of -1.66 milliseconds on July 5th, 2024, a new record may not be set in 2025. But there is a possibility of some days being around -1.5 milliseconds shorter, which will keep this unusual trend going. But why are the days getting shorter on these specific dates? A subtle natural rhythm is at play. Researchers have noted that when the Moon is far north or south of the Earth's equator, meaning the Moon's orbit is at a greater angle to Earth's equatorial plane, the Earth's rotation slightly accelerates. On those specific dates in 2025, the Moon will be significantly far from the equator in the northern or southern sky. For this reason, Earth's rotational speed may temporarily increase, just as we saw in mid-2020, 2021, 2022, and 2024. Besides the Moon's position, other factors also influence Earth's rotation in the short term. For example, seasonal atmospheric changes every year in the summer, June, July. Certain changes in the atmosphere and wind patterns often cause a slight decrease in the length of the day at that time of year. We have already seen that the shortest days of each year occur around the same time around July. Now the question is, why has the Earth collectively been spinning so fast in recent years? In the next chapter, we will delve deeper into the potential reasons. The recent acceleration of Earth's spin has presented itself as a puzzle to scientists. No one expected this, expressed Dr. Leonid Zatov, an expert on Earth's rotation from Moscow State University. For a long time, the assumption was that Earth's rotation was only slowing down. No one anticipated a sudden speed-up. So, what is the reason for this abrupt trend? First, many of the reasons behind the day-to-day variations are complex and lie within the Earth itself. Scientists say a major reason could be changes occurring inside the Earth, especially the dynamics of the liquid iron outer core beneath the surface. The flow and rotation of the hot liquid outer core, which lies beneath the solid crust and mantle, affect the entire planet's rotational speed. For instance, when the angular momentum of the inner core or other layers is exchanged, a slight acceleration or deceleration can be seen in the total rotational speed, much like a figure skater spinning faster when pulling her arms in or slower when spreading them out. Although the change in Earth's case is extremely small, scientists have noticed a particular phenomenon. The position of Earth's poles wobbles slightly each year, known as the Chandler wobble. Typically, this wobble has a range of 3 to 4 meters on the Earth's surface. But between 2017 and 2020, the Chandler wobble mysteriously almost disappeared, meaning the polar wobble temporarily ceased. Zadov and his colleagues speculate that there might be a connection between the cessation of the Chandler wobble and the acceleration of Earth's rotation, although the exact cause is still unknown. It could be the result of some change in mass distribution inside the Earth. Another major idea among geoscientists is the activity of Earth's liquid outer core and internal structure. Analysis of changes recorded over the last 50 years shows that the rotation of Earth's inner core has slowed slightly, adding a very small acceleration to the overall rotation. One study showed that, after accounting for various factors, the length of a day has decreased by about 0.0025 seconds, 2.5 milliseconds, compared to 50 years ago. This means the solid Earth is spinning slightly faster due to the slowing of the inner core. A study published in 2023 proposed that Earth's solid inner core speeds up and slows down its rotation in a cycle of about 60 to 70 years. It is thought that around 2009, this inner core rotation nearly paused for a while and then started to rotate slightly in the opposite direction. This could have a subtle effect on the Earth's total rotational speed and the length of the day. Although there is disagreement among scientists on this matter, it shows that unknown ongoing processes inside the Earth can also affect the length of our day and night. However, it's not just internal matters. Many external factors also affect the rotation speed, weather and wind. Atmospheric wind flows impact Earth's rotation. The Earth and its atmosphere collectively conserve angular momentum. So, during major weather events like strong El Niño or La Niña key years, the pattern of air circulation changes in such a way that the solid part of the Earth may have to spin slightly faster or slower. For instance, Earth's days are slightly shorter at certain times of the year in summer when there is a specific pattern of atmospheric flow. Conversely, days can be slightly longer in winter due to different wind patterns. Thus, seasonal and weather-related changes cause temporary variations. Ocean currents. Ocean water plays a role similar to the atmosphere. Ocean currents and tides can slightly affect Earth's rotation. For example, changes in equatorial currents or during strong El Niño events cause a redistribution of the ocean's momentum, which can slightly slow down Earth's rotation or, in other cases, speed it up. Changes in surface mass distribution. In the 20th and 21st centuries, polar ice has been melting rapidly, shifting mass from the poles towards the equator. As we discussed earlier, this is a trend that slows Earth's rotation, just as a skater slows down by extending her arms. The Earth's rotation slows slightly when mass moves towards the equator. Satellite measurements of Earth's gravity have shown that since the 1990s, Earth has become slightly more spherical, less oblate due to ice melt, and as a result, its rotation has slowed a bit. This means climate change is actually working too. Slow down Earth's rotation, not speed it up. But the acceleration the Earth was getting from the inner core's influence has been somewhat mitigated by this climate change effect.
Other man-made causes, it might be surprising, but creating large reservoirs and dams in the northern hemisphere and storing huge amounts of water has a slight effect on Earth's rotation due to the change in mass distribution. However, this effect is absolutely negligible and not enough to create an overall trend. Among all these different influences, what is the real cause? That is the million-dollar question. This is where scientists are scratching their heads. The magnitude of this recent acceleration, certainly only milliseconds, but large in scientific terms, is so great that it cannot be explained by weather or oceans alone. Zadov has said, the reason for this acceleration has not been explained. Most scientists believe its origin lies inside the Earth. Ocean and atmospheric models cannot show such a large acceleration. This suggests that a combination of several subtle factors is likely causing this change. In early 2024, there were indications that the Earth might start slowing down again, and Dr. Zadov had predicted that Earth's rotation would soon decelerate. But that prediction turned out to be wrong. At the time, instead, a new record for fast rotation was set in 2024. However, for 2025, Dr. Zatov says, "My guess is that we have already reached the minimum point. Very soon the Earth will start slowing down again." This means he believes the trend of fast rotation will now stop, and the Earth will return to its long-term trend of gradual slowing. All in all, several complex processes, mostly internal to the Earth, are at work behind the increase in Earth's rotational speed. Scientists are still not entirely sure which factor is responsible for how much, but various theories suggest that the combined effect of changes in the Earth's core, polar wobble, and other processes is responsible. This is an active area of research. It is hoped that in the coming years, we will get a clearer solution to this mystery. Scientists are offering various opinions and observing with great interest this strange modern change in Earth's rotational speed. As we heard from Dr. Leonid Zatov, he says the matter is unexpected and the cause is still unclear. Now let's hear the opinions of some other experts. Dr. Duncan Agnew, a geophysicist at the Scripps Institution of Oceanography in California, published a study on this topic in 2024. According to his observation, we are facing an unprecedented situation. The Earth is spinning so fast that we may have to make changes to our conventional timekeeping system. Another expert, Dr. Alistair Gunn, an astronomer at the Jodrell Bank Observatory, reassures the general public about this change. He meant that this small change will not affect our daily lives. So there is no reason to worry as long as its cause does not come from our own activities like climate change. Many researchers believe that this trend of faster rotation is temporary and the Earth will soon return to its previous slow pace. So there is nothing for the general public to fear. However, some caution is needed in certain technological areas. Scientists agree that it is important to keep an eye on this change from a timekeeping and technological perspective. In our next chapter, we will discuss how time is counted and synchronized with Earth's rotation, and what adjustments are being considered due to the recent changes. Overall, the scientific community is looking at this issue from two perspectives. One is pure scientific curiosity. How did the Earth suddenly accelerate? What is its geophysical cause? And the other is a practical view. What impact will this change have on our timekeeping and technological systems? And how should we deal with it? In both cases, this event has created a stir and opened the door to new research. We consider time as a fixed benchmark tied to the hands of a clock, but in reality, this benchmark is man-made, and we sometimes have to make adjustments to sync our timekeeping with the Earth's own rotation. The world's standard timeline, which we call Coordinated Universal Time, or UTC, runs according to the steady rhythm of atomic clocks. Yet the length of a day depends on the sun's position in the sky, which is related to the Earth's rotation. There's a conflict here. Earth's rotation is not uniform, but our atomic time standard is extremely uniform and regular. So, when the gap between the two widens, it has to be filled. Since 1972, global timekeepers have implemented a system called adding a leap second. When it is found that the difference between solar time according to Earth's rotation and atomic UTC has reached about 1 second, an extra second is added to the clock to reduce the difference. To put it simply, on a certain day, our clocks show DYY after DYY, and then the next day starts with 0 hours, 0 minutes, and 0 seconds. The first leap second was added in 1972, and since then, it has been necessary to do this every few years. It is worth noting that about 27 leap seconds have been added since 1972, on average once every few years, since the last leap second was added on the night of December 31, 2016. No new leap second has been added. For a long time, leap seconds have always been added. Because Earth's average rotation is slow, meaning Earth's rotational time falls behind. So the clock time has to be advanced occasionally by adding a second. But now, the situation has changed a bit. In recent years, Earth's rotation has been so brisk that in terms of time, the Earth seems to be getting a little ahead. As a result, For the first time, scientists are thinking that a negative leap second might be needed. A negative leap second would mean the opposite. We would have to subtract a second from our clocks to sync them with the fast-spinning Earth. Imagine, at the end of a June or December, the clock shows 0 hours, 0 minutes, and 0 seconds, right after 23 hours, 59 minutes, and 58 seconds. Skipping the second 23 hours, 59 minutes, and 59 seconds. This has never happened before. And it is not certain when it will happen, but it is thought that something like this might be necessary. Around 2028 or 2029, scientist Dr. Duncan Agnew's analysis showed that if Earth's current fast rotation continues, a 1-second difference with atomic time could develop by 2028. He calculated that, in reality, the trend of Earth's average rotation slowing down still persists somewhat due to climate change. If the polar ice had not melted, a negative leap second might have been needed 3 years earlier, around 2025. But because the mass of melting ice water has shifted towards the equator, Earth's rotation has slowed down a bit, delaying the need for a negative leap second by a few years now, likely needed around 2028, 2029, but implementing a negative leap second in practice is not so easy. In the world of technology, a 1-second discrepancy can cause major disruptions, as countless systems work in sync with time. It has already been seen in the past that adding a leap second has caused problems for some computer servers, and networks often servers would hang or crash, because many software programs are not properly prepared to handle an extra second. Now, if the opposite has to be done, suddenly subtracting a second from the clock, it will be even more challenging from a technological standpoint. In many systems, time has never gone backward, so a special plan is needed to manage it. To avoid problems, major tech companies have come up with various solutions. For example, Google uses a technique called leap smear for its server timeware. For several hours before and after a leap second, each second is made infinitesimally longer or shorter to smear out the extra second. This way, the clock does not need to suddenly show a 61 or 59 second minute, and the system adjusts gradually. A similar strategy might have to be considered for a negative leap second, so that the shock of subtracting a second is not felt directly, and time can flow smoothly. For example, take bank transactions or GPS satellite signals. These operate on extremely precise time. If a system doesn't know about a negative leap second, and during a transaction, one server thinks the time is 0 hours, 0 minutes, and 0 seconds, right after 23 hours, 59 minutes, and 59 seconds, because a second was dropped, while another server, following the old calculation, shows 23 hours, 59 minutes, and 59 seconds again. Because time went backward, the discrepancy between the clocks of the two systems could cause major problems. A second is nothing to us, but in the world of computers, even a slight mismatch in time can lead to a major disaster. In reality, the organizations responsible for international timekeeping, like IERS and others, are already moving towards making a policy decision on this matter. According to a 2022 decision, no leap second will be added or subtracted until 2035, allowing time to run, after which a future solution will be reached. This may mean that no leap second will be introduced in the next decade or two, and even if the Earth gets ahead, a negative leap second might not be used, and a slight difference between time and the Earth might be accepted. Of course, the debate on what will ultimately be done is ongoing, because it is not certain how technologically safe it is to subtract a second. Ultimately, the issue is that changes in Earth's rotation have become an important problem and a topic of practice in the world of timekeeping. Experts are already thinking about possible changes in time measurement methods to maintain synchronization between clock time and true solar time. The negative leap second, although never used, may be needed for the first time in reality, or alternatively, the idea of completely removing these minor adjustments from the timeline is also under consideration, such as the proposal to stop leap seconds after 2035. On one hand, there are technological challenges, and on the other, natural changes in time. All in all, we may have to be prepared for changes in our timekeeping methods in the future.
Now, The main question is, even if the Earth is spinning a few milliseconds faster, does it actually have any impact on our daily lives? Can you and I feel that the day has become slightly shorter? In reality, the answer is no. This has no direct impact on our daily lives. A millisecond is a thousandth of a second. Such a subtle change is not perceptible to humans, let alone the animal kingdom. Our bodies and the biological world operate in sync with the daily cycle of light and darkness, known as the circadian rhythm. If the length of the day were to change by minutes or hours, it might have some effect on the biological world or our sleep-wake cycles. But a millisecond level difference causes no change in natural or biological rhythms. The sun rises and sets at its specific times, and our day-night cycle continues and will continue just as it is. Some might jokingly ask, when the Earth is spinning a bit faster, will our weight decrease slightly? This is because, at the equator, objects weigh slightly less than at the poles due to the centrifugal force of Earth's rotation. But you'll be disappointed. A 1 millisecond change will have absolutely no effect on our weight. You won't suddenly become lighter due to such a small variation in Earth's rotational speed. Although there is no perceptible impact on daily life, there is a slight impact and a need for awareness in the fields of technology and scientific calculation. Our entire world is now tied together by a subtle time synchronization through GPS, satellites, internet servers, power grids, etc. Every millisecond can be important though the current change is so small that it won't be a direct cause of problems. If it accumulates, a slight adjustment is needed to sync the time. For example, let's take the GPS system. GPS satellites follow extremely accurate atomic time and determine our location through time signals. If the Earth's rotation changes very slowly, it is not a major problem for the GPS system right away, because corrections are made constantly. But in the long term, if a few milliseconds of difference accumulate, it could lead to slight errors in position calculation. Fortunately, GPS and astronomers are aware of these small variations and regularly adjust their calculations. Again, in electric power grids for frequency control or in the stock market's high-frequency trading, every millisecond counts. However, these systems follow international time signals and operate automatically, so a rotational discrepancy in the Earth does not have a direct impact. Rather, adjustments are only needed if the time signal itself has to be changed, for example, through a leap second. Let's think about it differently. If the Earth's rotation suddenly increased or decreased significantly, say a day became 23 or 25 hours instead of 24, imagine how widespread the impact would be. Our calendars, clocks, the biological world, everything would be thrown into chaos. But the change we are talking about now is negligible in comparison. Imagine for a moment, if you found out tomorrow morning that today was an hour shorter. Everyone would be at a loss, unable to finish their office work. Some might blame the clock, others the calendar itself. Of course, this is just imagination. It's not happening in reality. And scientists have said that this millisecond change will not disrupt our daily activities in this way in the future. But it's worth thinking about how such a small change in time can feel like a major shift in our imagination. Nevertheless, this event has taught us how much attention to detail is required in the world of technology. When 1 millisecond becomes important, it shows how advanced our technology is. For example, in determining the orbits of the International Space Station or satellites, even tiny units of time have to be considered. Although this slight acceleration of Earth's rotation won't require immediate changes to their orbits, the matter of fine-tuning time, calculation, and position determination in these systems must be kept in mind. All in all, it can be said that we are not feeling its reflection in our daily human activities. But the global time and technology infrastructure is noticing and adapting to it. In that sense, the event has certainly given us food for thought, just as you are watching this documentary now. But in reality, it will not change our sleep or work schedules today, tomorrow, or in the next year. Of course, in the long term. If the Earth were to actually start spinning much faster or slower, which would carry geological or climatic signals, it would certainly have a major impact on our lives or the environment. The seasonal cycle, tides, day-night temperature differences, etc. would change. Fortunately, we are not in such a situation, and the current changes are within the range of natural short-term fluctuations. So far, we have seen that even though Earth's rotational speed has increased, it is not having any immediate negative impact on human life. Our daily life follows and will continue to follow the cycle of sunrise and sunset. However, some fine-tuning may be needed in the precise measurement of time in technological fields, and work is underway on that. Most importantly, this small change has opened our eyes to a larger context. Our planet and its processes are never completely static. They are always changing. Now, in the conclusion, we will discuss what we have learned from this event and what our preparation for the future should be. This subtle change in Earth's daily rhythm reminds us of several profound things. Firstly, how dynamic our familiar daily nature really is. We have taken the 24-hour day as a constant. But in reality, the Earth is changing with every breath. Sometimes a little faster, sometimes a little slower. The change is so small that it doesn't register on our senses, but sensitive instruments and science can detect it. This should make us humble. Even what seems certain in nature can change. Secondly, this event challenges scientific understanding. For a long time, we thought Earth's rotation was only slowing down. Now we suddenly see it speeding up. We are still struggling to fully understand the reason behind it. Scientists are investigating this unexpected change and proposing new ideas, core dynamics, Chandler wobble, etc. This is an exciting topic for both geology and astronomy. The idea that our planet's internal dynamics can also affect the length of a day was once unimaginable. Solving this puzzle will give us new knowledge about the Earth's interior. Thirdly, it reveals both the capabilities and limitations of our technological infrastructure. If a millisecond discrepancy raises questions about changes in our computer networks and timekeeping strategies, it proves how advanced we have become in measuring time. At the same time, it shows that we need to prepare our systems in advance. For such unexpected changes, more advanced methods for seamlessly managing things, like adding or subtracting leap seconds, need to be developed to avoid disruptions in the internet and information technology systems. Fourthly, the context of climate change also comes up here. Melting ice, rising sea levels, the effects of these are not limited to weather or climate. Their subtle reflection is also seen in Earth's rotation. This means that human activities can have an impact on such a subtle level that we hadn't thought of before. The Earth's day can become slightly longer or shorter due to the changes we create. Although the main reason for the current fast rotation may not be man-made, the fact that climate change is influencing Earth's speed by slowing it down reminds us of our responsibility and the need for caution. Fifthly, this event shows us that change is the only constant in the universe, no matter how finely we consider things. There is no reason to think of a large body like the Earth as a static constant just because it is spinning in space. Rather, it is changing on both long and short timescales. The event of the day becoming slightly shorter is a small example of that greater truth. What preparations should we make for the future? Nothing may be changing directly from tomorrow, but for those who work with Earth's day-night cycle and time, monitoring and planning are extremely important. International time standard organizations like IERC have already started discussions on timekeeping methods. Questions like whether to keep leap seconds in the future, how to handle a negative leap second, etc., are being addressed. It may be that one day our daily clock counting will diverge slightly from solar time. or a major reform will be introduced. This will depend on the behavior of Earth's rotation and how quickly technology can adapt. Above all, this event teaches us to be humble and reminds us how alive and unpredictable our planet is. We take the daily cycle of sunrise and sunset for granted, but nature shows us that changes occur even within it. Even a massive planet like Earth sometimes changes its routine slightly, and our technology and knowledge have to adapt to it. From this, we learn that there is no such thing as stasis on a cosmic scale. Change is happening even at the smallest level. Narrator: in today's discussion, we heard a unique story of time and the Earth where even a few milliseconds of variation can become an exciting chapter. May the mystery of Earth's fast rotation continue to expand the boundaries of our knowledge. And may we be ready for any surprise, because we live in a world where things stranger than fiction can indeed happen. The length of our day may have become slightly shorter, but the horizon of our knowledge has expanded immeasurably.